Despite its widespread corporate adoption, or maybe because of its widespread corporate adoption, a debate persists within the Agile community regarding whether the Scaled Agile Framework, or SAFe, represents a legitimate scaling of Agile principles or an institutional regression towards prescriptive top-down software development disguised beneath modern terminology. This video aims to answer the question, is SAFe Agile? I'm Jeremy, the Internet Scrum Master. I have 20 years in software development and 10 as a full-time Scrum Master, and I'm a certified SAFe Scrum Master and certified Scaled Agilist. Let's dive in. The corporate demand for structured frameworks that promise to synchronize a large number of developers while maintaining strategic business alignment has driven substantial commercial growth in the Agile sector over the past decade. Industry statistics from the 16th and 17th State of Agile reports reveal that scaled Agile practices have transitioned from experimental adaptations to standard corporate strategies. Currently, 71% of surveyed organizations use Agile within their software development lifecycle. Agile methodologies are increasingly operating far beyond traditional IT departments. Adoption within engineering and research and development sectors reached 48%, a 16% year-over-year increase, while business operations and marketing report adoption rates of 28% and 20% respectively. While these figures unequivocally demonstrate SAFe's commercial popularity, widespread market adoption is not synonymous with alignment to the Agile Manifesto. The framework is frequently adopted precisely because its multi-layered architecture fits seamlessly into existing reporting lines, traditional budgeting cadences, and corporate cultures. This structural alignment facilitates initial procurement and executive approval, but simultaneously introduces friction when the operating model is evaluated against the core tenets of Agile software development, particularly from seasoned Agile practitioners. Prominent software engineers and original Agile Manifesto authors describe this commercialization as the Agile Industrial Complex. Martin Fowler, an original signatory, argues that this complex has weaponized Agile terminology, optimizing for transaction revenues, consulting fees, and certifications over genuine organizational transformation. The underlying philosophy driving this complex is frequently compared to Taylorism, a 19th century industrial management theory popularized by Frederick Taylor that views workers as standardized interchangeable resources needing strict process control rather than autonomous creative problem solvers. Dave Thomas, not the Wendy's guy, another original manifesto author, expanded upon this in his Agile is Dead presentations. Thomas argued that the Agile industry has debased the meaning of the word entirely, replacing the concept of agility, which involves continuous improvement, small steps, and learning from failure, with rigid processes and frameworks that stifle innovation. Organizations purchasing SAFe often expect a formulaic cure-all, resulting in faux Agile implementations, where the terminology is aggressively adopted but the underlying values of continuous delivery and self-organization are ignored. Thomas posits that real agility is not a noun to be purchased, but an adjective describing how an organization behaves. A team can utilize traditional tools and still operate with agility, or they can utilize SAFe and remain entirely rigid. The theoretical criticisms of SAFe often focus deeply on its structural lineage and what experts describe as a deviation from organic agility towards prescriptive compliance. Ken Schwaber, co-creator of the Scrum framework and a signatory of the Agile Manifesto, famously characterized SAFe as unsafe at any speed. In a highly debated 2013 publication, Schwaber posited that the framework represents a direct process-heavy rebranding of the Rational Unified Process, or RUP. RUP, originally developed by Rational Software and later acquired by IBM, was a highly prescriptive, heavily documented software engineering framework that the Agile Manifesto was specifically written to oppose. Critics argue that SAFe, much like RUP, relies on highly complete, one-size-fits-all blueprint that overemphasizes predefined templates, specialized roles, and administrative processes over localized human interaction. Martin Fowler similarly characterized SAFe as shitty Agile for enterprises, pointing to its visual complexity, often compared to a highly intricate transit map as a stark departure from the deliberate simplicity of the Agile Manifesto. Proponents of SAFe vigorously defend its ideological foundation by highlighting its integration of lean thinking, systems engineering, and extreme programming practices. At the localized team level, SAFe explicitly mandates the use of standard Agile practices, utilizing cross-functional Scrum and Kanban teams that rely on test-driven development, continuous integration, refactoring, and pair work. Proponents argue that standard Agile methodologies like Scrum offer absolutely no guidance for managing enterprise portfolios or coordinating dozens of interrelated teams. This leaves a severe governance vacuum in large organizations that SAFe successfully fills with lean economic principles, synchronized release cadences, and structured dependency management. As Agile practitioner Ron Jeffries noted, while SAFe may not be pure Agile, its guidance at the portfolio and program levels provides a structure mechanism for large organizations that's vastly superior to having no guidance at all, even if it inherently limits an organization's progress towards truly high-functioning agility. To objectively determine if SAFe is genuinely Agile, its operational mechanisms have to be evaluated directly against the 4 foundational values of the Agile Manifesto. This comparison reveals a profound structural divergence between the lightweight, human-centric philosophy of standard Agile and the highly governed, predictable execution model engineered by SAFe. Individuals and interactions over processes and tools. The first value of the Agile Manifesto asserts that human collaboration, psychological safety, and individual agency must take precedence over standardized procedures and software tools. Critics contend that SAFe systematically subverts this value by introducing a dense, highly prescriptive system of processes, roles, and administrative templates that restrict organic human interaction. Individual interactions in a SAFe environment are heavily structured around predefined cadences, Scrum of Scrums, Agile release train syncs, and application lifecycle management tools like Jira. This extreme process density can lead to the emergence of what practitioners term dark Scrum or dark Agile, where developers are treated as standardized resources pushed through a corporate process crevice rather than autonomous creative problem solvers like they are. SAFe's defenders counter this critique by pointing to the inescapable realities of enterprise scale. In an enterprise with thousands of developers, standard processes and tools are an absolute prerequisite for enabling interactions across disparate departments. Without a shared language, common roles, and structured communication channels, large-scale systems degrade into chaotic communication failures. SAFe's design dictates that its structured layers act as an administrative shield, theoretically protecting team-level self-organization from enterprise complexity. Working software over comprehensive documentation. Agile methodologies prioritize the frequent release of functional high-quality software as the ultimate measure of project progress. SAFe aligns with this in theory by incorporating XP engineering practices to ensure built-in quality at the team level, and it mandates a bi-weekly system demo where the entire art must demonstrate an integrated increment of the system to stakeholders. Despite the theoretical mandate for continuous delivery, SAFe implementations historically rely on late cycle hardening periods during the innovation and planning or IP iteration. This directly violates the Scrum and Agile requirements that every single sprint must yield a fully done release quality increment. By utilizing the IP iteration for late-stage stabilization and manual testing, the phase is frequently converted into a holding pen for deferred technical debt and delayed integration, undermining the concept of working software. Customer collaboration over contract negotiation. Standard Agile advocates for direct ongoing collaboration between the development team and the end customer, relying on unfiltered feedback to build the correct product. In small team Scrum, the product owner represents the user and collaborates daily with developers. In SAFe, this direct link is systematically severed. The framework splits product management responsibilities across a hierarchical chain. Epic owners and portfolio managers define strategic initiatives at the top level, product managers own the program backlog and prioritize features for the release train, and product owners are relegated to merely writing stories and managing team-level backlogs. This division leads to a heavily mediated telephone game scenario where developers receive highly processed, decoupled requirements. Direct interaction with real customers is replaced by interactions with internal proxies, severely reducing the development team's ability to build user empathy and adapt rapidly to real-world usage patterns. Responding to change over following a plan. Responding to change requires empirical process control where plans are treated as flexible hypotheses that must be validated through rapid deployment. SAFe attempts to balance adaptability with enterprise predictability through program increment planning, or PI planning, a highly structured 2-day event where all teams on an ART map out work for the next 8 to 12 weeks. Critics argue that PI planning operates as a series of rigid fixed commitments that closely resembles a localized cyclical waterfall cycle. During this event, teams identify dependencies, establish a program board with physical or digital red threads, and commit to PI objectives. Once these objectives are locked in and the dependencies mapped, changing direction midway through the PI introduces massive organizational friction as dependencies across multiple other teams must be renegotiated. Consequently, the operational focus often shifts from delivering value based on new empirical learnings to strictly executing the plan agreed upon during PI events. Deconstructing engineering principles. Dave Farley, a prominent software engineer and author of foundational text on continuous delivery, highlights that Agile projects must be reactive, adaptive, and evolutionary. Farley notes that SAFe is widely disliked by long-term Agile practitioners because it provides an illusion of agility while preserving traditional management structures. The Agile Manifesto emphasizes early, frequent, and continuous delivery of working software. SAFe aligns with this in theory through its continuous delivery pipeline, promoting the mantra develop on cadence, deliver on demand. However, implementing true continuous integration where developers merge code into a shared mainline multiple times a day, verified by an automated build and test suite, becomes highly complex in a SAFe environment. In an environment containing 50 to 150 developers across multiple teams, team-level continuous integration is entirely insufficient. SAFe mandates ART-level continuous integration, requiring integration across all teams on the release train. This execution frequently breaks down due to inadequate self-testing code. Enterprise code bases are often tightly coupled and lack comprehensive automated test suites. Without self-testing code, merging into the mainline merely compiles the software without validating system functionality, providing a dangerous false confidence. Additionally, in complex cyber-physical systems involving both hardware and software, continuous end-to-end integration is often economically or physically unfeasible. SAFe's guidance suggests that evaluating the economic trade-offs of integration frequency, while this represents a pragmatic corporate compromise, it inherently introduces longer feedback loops, increasing the risk of late-stage integration failures, and directly contradicts the immediate delivery models championed by pure Agile engineering. The necessity of the release train itself is viewed by critics as a remedial practice presented as an ultimate solution. The train is only required because the work has been artificially partitioned across teams in a way that requires massive coordination to put it back together, rather than solving the root problem of architectural coupling. To address the Agile principle of welcoming changing requirements for the customer's competitive advantage, SAFe operationalizes lean engineering concepts, specifically set-based design, codified in SAFe Principle 3, assume variability, preserve options. In traditional point-based engineering systems, teams commit to a single design option early in the development lifecycle. If empirical data later reveals that the chosen design is flawed or inferior, the product suffers from massive downstream rework, delays, cost, and overruns. If empirical data later reveals that the chosen design is flawed or inferior, the project suffers from massive downstream rework, delays, and cost overruns. Set-based design mandates that teams identify and simultaneously vet multiple viable design paths or technical solutions. Teams use trade-off curves and design guidelines to characterize feasible sets, progressively eliminating alternatives only when they are proven empirically inferior or infeasible through analysis and testing. The process involves two main phases: identify and implement. During identification, the team assesses various project elements against targets, maintaining options. Implementation and refinement of design details only occur once enough data is gathered to narrow down to the optimal solution. This lean concept maximizes design efficiency, a measure of flexibility, cost, and speed, reducing the long-term cost of development in highly variable environments and preventing organizations from becoming locked into suboptimal technical solutions. While this approach perfectly aligns with the Agile ethos of welcoming change, it requires a profound structural shift away from traditional fixed scope, fixed budget project management, which typically demands a single design choice upfront to satisfy early contract negotiations. To prioritize features and coordinate backlogs across multiple teams, SAFe introduces quantitative prioritization via the weighted shortest job first formula. Developed as a practical application of lean product development principles, WSJF sequences backlog items to deliver the maximum economic benefit in the shortest time. CD3, or cost of delay divided by duration, says that if a product team quantifies nothing else, they must quantify the cost of delay. In actual absolute financial terms, example, dollars per month lost if the feature is not delivered. This absolute financial metric reframes prioritization as a strict economic discipline rather than a subjective negotiation among stakeholders. SAFe modified this approach to make it more palatable for widespread enterprise use. SAFe calculates WSJF by redefining the cost of delay as a sum of three relative parameters evaluated on a modified Fibonacci scale divided by the relative job size. The user business value parameter is the relative importance of the feature to the end user or business scored against other features. The economic focus is to maximize immediate customer utility and direct returns. The time criticality parameter is the relative rate at which the feature's value decays over time or the presence of a market window. The economic focus is to minimize the cost of waiting and meet market deadlines. The risk reduction / opportunity enablement parameter is the relative degree to which work mitigates risk or enables downstream value. The economic focus is to enhance technical architecture and open strategic options. The job size / duration parameter is the relative effort or story point estimation required to develop and integrate the feature. The economic focus is to optimize resource utilization and prioritize quick wins. While SAFe's version of WSJF represents a disciplined attempt to apply lean economics, the modification introduces an operational vulnerability. By reducing absolute business value of dollars to a relative unitless number like story points and simply adding it to other unitless numbers with high variance like time criticality, the inputs become highly subjective estimates rather than empirical economic facts. As Agile practitioners have pointed out, SAFe-style cost of delay is no longer mathematically useful as a decision rule for trade-off decisions. For example, if Project A provides $1 million of value with a cost of delay of $100,000 per month, and Project B provides $500,000 of value with a cost of delay of $250,000 per month, the model dictates scheduling Project B first to maximize lifecycle profits. By utilizing arbitrary Fibonacci points across three disparate categories, SAFe obscures these absolute economic realities. Critics argue that this relative approach can easily be manipulated by product managers who simply artificially inflate the time criticality score to justify preconceived strategic roadmaps, creating an illusion of objective prioritization. Furthermore, centralizing the ordering of the program backlog via WSJF restricts the team's ability to pivot based on localized feedback, as any shift in priority requires the recalculating of the WSJF metrics across the entire release train. As enterprises adopt scaling frameworks, the demand from executives to quantify return on investment and measure framework compliance has led to the proliferation of Agile Maturity Models. These models represent a fundamental paradox, attempting to systematically standardize, score, and audit a philosophy that's inherently based on empirical self-correction, contextual adaptations, and fluid human dynamics. The foundational SIDKey Agile Measurement Index, or SAMI, requires a 5-step value-based roadmap to agility. The model is designed to guide organizations by instilling new values at each progressive stage. Level 1, collaboration, enhancements in communication and building collaborative, motivated teams. Level 2, evolutionary, focus on early and continuous software delivery and evolutionary requirements. Level 3, effective, Adaptive planning, risk-driven iterations, and client-driven continuous satisfaction. Level 4, adaptive, high human centricity, self-organizing teams, and frequent face-to-face communication. Level 5, encompassing, full enterprise integration of Agile values across all business operations. Building upon SAMI, researchers developed the Scaled Agile Framework Maturity Model, extending it to include 19 SAFe-specific enterprise practices. The Scaled Framework Maturity Model was deemed the most comprehensive for large organizations due to its completeness, scalability, and precision. To minimize the subjectivity, inconsistency, and high resource cost associated with manual Agile maturity assessments, a pivotal case study was conducted at the Swedish Tax Agency, a large government administrative authority utilizing SAFe. Researchers investigated how the evaluation metrics of the SAFe maturity model could be automated using process mining and data extraction directly from application lifecycle management systems like Jira and GitHub. The case study revealed that while high-level competence metrics such as sprint cadence alignment, PI planning attendance, and story point velocity predictability could be systematically automated, the qualitative elements of true agility could not. Elements such as team psychological safety, technical excellence, and genuine self-organization behaviors completely evade data log capture. Consequently, while automation effectively reduces the administrative cost of compliance tracking, it heavily incentivizes transformation theater. Teams learn to optimize the tool inputs to reflect high SAFe maturity on digital dashboards, while their actual capacity to adapt to market changes remains entirely static. The financial sector, where I've spent the vast majority of my career, is one of the fastest growing adopters of SAFe, driven by strict regulatory compliance mandates that demand clear audit trails, rigid governance, and predictable delivery dates. These legacy constraints make standard unguided team-level agility nearly impossible to implement at scale. SAFe appeals to banking executives because its multi-layered structure maps cleanly onto existing hierarchical structures in traditional annual budgeting cycles, providing a sense of control. However, in highly matrixed banking environments, organizations frequently form SAFe teams by simply renaming existing functional silos rather than creating genuinely cross-functional autonomous units. This creates a scenario where theoretically agile teams remain highly dependent on external database administrators, security personnel, or change-approved release committees. This halts independent delivery and turns the Agile release train into a series of bureaucratic toll gates rather than a continuous pipeline of value. If evaluated strictly by the ideological metrics defined by the 2001 Agile Manifesto, which demands localized empowerment, the minimization of formal process, empirical adaptation, and unmediated customer collaboration, SAFe cannot be categorized as genuinely agile. By its very design, SAFe is a highly prescriptive, process-dense framework engineered to establish predictability, governance, and alignment across massive organizational structures, inherently prioritizing process compliance over organic human interaction. However, dismissing SAFe outright as anti-agile ignores the pragmatic, inescapable realities of modern enterprise systems engineering. While pure Agile operates perfectly for an independent team of 7 developers building a web application, it offers absolutely no architectural or governance guidance for a highly regulated enterprise requiring the synchronized effort of 50 teams working on a tightly coupled legacy system. Ultimately, SAFe acts as a pragmatic administrative scaffolding that wraps around the complexity of large organizations that cannot or will not reduce their inherent structural and architectural coupling. SAFe introduces agility at the team level where standard Scrum, Kanban, and XP practices are deployed, but it relies heavily on traditional top-down governance at the portfolio and program levels to ensure synchronization. For massive enterprises, SAFe provides a valuable roadmap to align hundreds of developers, which is exceedingly difficult to achieve with lighter, unguided, scaled approaches. Yet, this alignment extracts a heavy toll. It institutionalizes dependencies rather than breaking them, adds massive administrative overhead, creates proxy layers between developers and customers, and establishes rigid planning boundaries that severely limit real-time adaptability. SAFe is agile only when implemented with a genuine underlying commitment to lean principles and continuous technical excellence. It becomes unagile when wielded merely as a process checklist to maintain a command and control status quo. Here are some strategic recommendations for enterprises who want true agility. Prioritize structural descaling before process scaling. Before implementing a heavy framework, aggressively attempt to simplify the team topology and software architecture. Every dependency that can be eliminated through architectural refactoring, such as transitioning to microservices and modular APIs, or team restructuring, forming cross-functional teams, directly reduces the need for heavy coordinated frameworks. Administrative process must never be utilized as a permanent bandage for poor system design. Treat SAFe as a transitory stopgap, not a final destination. Organizations should adopt SAFe with an evolutionary transitional mindset. The ultimate goal of Agile transformation must be a progression towards greater decentralization, continuous delivery, and organic team autonomy. Features of the SAFe framework engineered solely to manage dependencies, such as the program board, release trains, and complex routing metrics, should be viewed as temporary mechanisms. The strategic focus must remain on continuously refactoring the underlying system to ultimately eliminate the need for those coordination mechanisms entirely. Enforce non-negotiable engineering discipline. A scaled framework will inevitably collapse if the underlying team-level delivery engine is defective. Enterprises must invest heavily in modern XP engineering practices, specifically automated testing suites, continuous integration, and infrastructure as code. A robust definition of done must be strictly enforced at the team level to ensure that no undone work or tech debt is deferred to late-cycle hardening sprints or integration periods. Without technical excellence, agility at scale is impossible. Establish a dynamic feedback loop to adapt the framework. Organizations must avoid the trap of treating SAFe as an unchangeable blueprint. Every enterprise possesses a unique market position, regulatory context, and a technological profile. Leaders must actively use empirical feedback and continuous retrospectives to constantly tailor, prune, and modify the framework's processes to fit their specific reality. If an administrative ceremony, artifact, or proxy role does not actively deliver tangible value or reduce systemic friction, the organization must possess the empirical courage to eliminate it entirely. Well, that's all for today. Thanks for sticking around to the end. If you find this sort of Agile Scrum information useful, consider liking and subscribing. Until next time, thanks and take care.